Soil lecture number 5, soil's weight and volume relationship. A soil sample is consisted of 3 main components. So in a soil sample, we have solid particles, the orange particles that you see here. So we have solid soil particles, and the space between these particles is filled with liquid and gas. So we have 3 main components and 3 main phases in a soil sample. It's consisted of solid particles, which are basically weathered rock particles. Then between the particles we have liquid or water, and also between the solid particles we may have air. So again, soil has 3 main components or three main phases: gas or air, liquid or water, solid or weathered rock particles. The combination of air and water, or the space between the solid particles, or the space not occupied by solid, is called void. For engineering purposes, to be able to calculate volume when we know weight or weight when we know volume, we use what you see in this slide, which is called phase diagram. We have 3 phases of air, water, and solid. We draw this rectangle. So we have a rectangle. We divide it into 3 sections. Each section represents 1 component of soil. So we have air, water, and solid particles. Then on one side we do the weight calculation, and the other side we do the volume calculation. So we have weight of sample. This is total weight of our soil sample. We can divide it to weight of air, which is 0. Air doesn't have a weight. It's weightless, so weight of air is 0. Then we have weight of water, and here we have weight of solid particles. And it's important that you know total weight is equal to weight of air plus weight of water plus weight of solids. And since this one is 0, total weight of a soil sample is equal to weight of water plus weight of solids. Then on the other side, we look at the volumes. So we have total volume of soil sample. We have volume of solids in our soil sample. Then we have volume of air, volume of water, how much water we have, And as I mentioned in the previous slide, when we add air and water together, it's called void. So we also have volume of voids. And again, total volume is equal to volume of air plus volume of water plus volume of solids. And remember that volume of void is equal to volume of air plus volume of water. So we can say total volume is also equal to volume of void plus volume of solids. So when we know some of these informations, we can actually complete our phase diagram, and then we can calculate properties of soil. An example is void ratio. We use letter E, lowercase e, to show void ratio. Void ratio is the ratio of volume of voids divided by volume of solids. So volume of void divided by volume of solids. It's how much void there is between the solid particles. And it's a good number, it's a good representation for permeability, also compressibility and shear strength. Higher void means higher permeability, but it can have a negative effect on the strength. So void ratio, E, is equal to volume of void, VV, divided by volume of solids, VS. The next property is called porosity, and it's the ratio of volume of voids. So again, we are looking at volume of voids, but this time we divide it by total volume. Volume of voids to total volume, and it's a percentage, so you need to multiply by 100. It shows the amount of space available within the soil for air and water to move through the soil, and it can impact plant root growth, water infiltration, aeration, and overall soil health. For engineering properties, we usually look at void ratio. Void ratio is important for like agricultural application. Porosity can be something that can help. So for porosity, we use letter N, and it's volume of void divided by total volume of a soil sample. Another property that is important, especially for engineering application, is degree of saturation. How much water we have, how saturated the soil sample is. So we use letter S for saturation, and it's now volume of water. So volume of water divided by volume of void. The voids between solid particles, what percentage of that void is filled with water? That is degree of saturation. What percentage of voids between the particles is filled with water? So it's the ratio of volume of water divided by volume of voids. It has an impact on soil physical properties, strength, stability, permeability, and water holding capacity. Next, we have water content, which we talked about this before. It's the ratio of, now we are talking about weight. So it's the ratio of weight of water divided by weight of solids. Weight of water divided by weight of solids. A physical property of materials is unit weight. And you see that a lot when you're talking about construction materials. Unit weight is weight of material divided by its volume. So the unit is usually pound per cubic feet. That's the general definition of unit weight. Weight of a material divided by its volume. When talking about a soil sample, we may talk about two different types of unit weight: a moist unit weight or a dry unit weight. Moist unit weight, we use this symbol, which is called gamma, to show moist unit weight. So gamma is equal to total weight divided by total volume. It's total weight of soil, including weight of water, divided by total volume of a soil sample. This is moist or wet dry unit weight. Again, we are dividing total weight by total volume. Now, dry unit weight, which we use gamma D. Again, this symbol is called gamma, and this is for dry. So dry unit weight, or gamma D, is dry weight divided by total volume. So this is dry weight, or we also call it weight of solids, divided by total volume. So moist or wet unit weight is gamma. Dry unit weight is gamma D, or gamma dry. Another physical property of materials is a specific gravity. A specific gravity is, again, the general definition, specific gravity is unit weight of material divided by unit weight of water. Again, this is the general definition for a specific gravity. The specific gravity of cement, aggregate, you calculate unit weight of cement or aggregate and divide it by unit weight of water. It gives us an idea to compare a material, a weight of material, to weight of water. So, if you have same volume of two different materials, one being water, the other one your soil sample, and then a specific gravity of your soil is 2.6, it means that in the same volume, weight of soil is 2.6 times weight of water. And remember that a specific gravity of water is always 1. Again, a specific gravity of water is always 1. Then we calculate a specific gravity of soil. We have 2.6. What does it mean? It means that soil sample, if we have same volume of soil and water, weight of that soil sample is 2.6 times weight of water. A specific gravity of sandy soil is usually around 2.65, and clay and silt, it can be anything between 2.60 to 2.90. So what is important for us is a specific gravity of solids. So we said that a specific gravity is a unit weight of a material divided by unit weight of water. So a specific gravity of solids is unit weight of solids, which is Ws divided by volume of S divided by unit weight of water. Gamma W is unit weight of water. Again, this is something that you need to remember. So a specific gravity of water is 1 unit weight of water, which we use gamma W, is given to us. It's weight of water divided by volume of water. It's weight of water divided by volume of water, and it's equal to 62.4 pound per cubic feet. So again, a specific gravity of soil is unit weight of soil divided by unit weight of water, which is unit weight of solids divided by unit weight of water. Unit weight of solids is weight of solid divided by volume of solid. So this is the general formula to calculate a specific gravity of solids. We have weight of solids, volume of solids, and unit weight of water. You can rearrange this formula to two different arrangements or shapes. All three of these formulas, they are the same formula with different arrangements. So if you need to calculate a specific gravity, use the first arrangement. If you need to calculate volume of solids, use the second arrangement. And if you need to calculate weight of solids, use the third arrangement. One more time, reminder that unit weight of water is always 62.4 pound per cubic feet in room temperature, and a specific gravity of water is 1. Now let's look at an example for soil weight and volume relationships. The weight of a chunk of moist soil sample. So we have a soil sample. It has air, water, and solid components. The total weight is 45.6 pounds. The volume of the soil chunk measured before drying, so the total volume is 0.4 cubic feet. After the sample is dried out in an oven, its weight is 37.8. So dry weight is 37.8 pound, and we said that weight of air is 0. Also given is the specific gravity. So a specific gravity of solids is 2.65. This is total weight, this is total volume, this is weight of solid, this is GS. The question is asking us to calculate water content, unit weight of moist soil, water content, unit weight of moist soil, void ratio, porosity, and degree of saturation. In order to do this, we need to complete this phase diagram. So one more time, total weight, total volume, and weight of solids are given. We know that total weight and again weight of air is 0. So total weight is equal to weight of water plus weight of solids. So from here you can calculate weight of water as total weight minus weight of solids. So weight of water is 7.8 pounds. We have all the numbers on the weight side. Now we need to calculate numbers on the volume side. The question also provided a specific gravity of solids, which is 2.65. And earlier we went over the formula for a specific gravity of solids, which is weight of solids divided by volume of solids times gamma W. Or if we rearrange it, we can have volume of solids is equal to weight of solids divided by GS times gamma W. Again, these two are the same formula with different arrangement. So we have weight of solids, GS, a specific gravity of solids, is also given, and we know what is unit weight of water. Again, remember unit weight of water is 62.4 pound per cubic feet. So we plug in the numbers in this formula, and we have volume of solids. Next, we need to calculate volume of voids, volume of air, and volume of water. So volume of void is equal to volume of void is total volume minus volume of solids, which is 0.4 minus 0.20. So this is our volume of void, which is 0.17 cubic feet. Next, we need to calculate volume of water. And for water, a property that we have is gamma W of water is 62.4 pound per cubic feet. And gamma W is weight of water divided by volume of water. So if we rearrange this one, we can calculate volume of water as weight of water divided by gamma W. Weight of water is 7.8 pound. Gamma W is 62.4 pound per cubic feet. So you can calculate volume of water as 0.13 cubic feet. And the last thing that we need to calculate is volume of air. You can calculate that using two different formulas. So we said that total volume is equal to volume of air plus volume of water plus volume of solids. So from here, you can calculate volume of air as total volume minus volume of water minus volume of solids. We also know volume of void. Void is volume of air plus volume of water. So from here, you can calculate volume of air as volume of void minus volume of water. Here I used this formula, but you can use the first one too. It should give you the same number. And then we have volume of air as 0.04 cubic feet. Now that you have all these numbers, you can calculate whatever was asked from you. So the question asked us for water content, which is weight of water divided by weight of solids times 100. Water content is 20.6%. So if we have our phase diagram, air, water, solids, then we have total weight of air, which is 0, weight of water, and weight of solids. It's weight of water divided by weight of solids. Then on the other side, we will have total volume, volume of air, volume of water, volume of solids. And here is our volume of void. Unit weight. Unit weight is total weight divided by total volume. So total weight divided by total volume. This is pound, this is cubic feet. So you get pound per cubic feet. Void ratio. Void ratio is volume of void divided by volume of solids. So it's volume of void divided by volume of solids. Porosity is volume of void divided by total volume times 100. And degree of saturation porosity is volume of void divided by total volume, and degree of saturation is how much water we have in the voids. So it's volume of water divided by volume of void times 100. Example number 2. We have 100% saturated soil. So 100% saturated means that S is 100% or 1, and degree of saturation is volume of water in void. So if this is equal to 1, that means volume of water is equal to volume of void, which means that volume of air is 0. There is no air between the particles. All the space between the solid particles is filled with water, and that's why it's called 100% saturated soil. 100% saturated soil has a wet or moist. Wet or moist are the same. Unit weight of 120 pounds. So gamma is 120 pounds per cubic feet. The water content of this saturated soil, the water content is 36%. The question is asking us to find void ratio and a specific gravity of solids. Moist unit weight is 120 pounds per cubic feet. We will do the calculation for a unit volume. A volume of 1 cubic feet. Then gamma, which is weight divided by volume, is equal to 120 pounds per cubic feet. Volume is 1 cubic feet, which means that our total weight is 120 pounds. This is the assumption that we will use for this question. We know that the moist unit weight is 120 pounds per cubic feet. In order to make the calculations easier, we assume that we are doing the calculation for a unit volume, a volume of 1 cubic feet, and for 1 cubic feet, weight of soil is 120 pounds. So we have total weight 120 pounds, total volume 1 cubic feet. That is our assumption. This is our assumption. Volume is 1 cubic feet And with a unit weight of 120 pounds per unit area, for 1 cubic feet, the weight of sample is 120 pounds. Then we also know total weight is weight of solids plus weight of water. So weight of water plus weight of solids is 120 pounds. The question also told us that water content of this soil sample is 36%. So that's another thing that we know. Water content, which is weight of water divided by weight of solids, is 0.36. And we need to use these two formulas to solve for weight of solids and weight of water. In order to do that, first you look at the second formula, rearrange this formula, and from this formula we know that the weight of water is equal to 0.36 times weight of solids. Then here, instead of weight of water, we put 0.36 weight of solids. So we use this, and instead of weight of water, we put 0.36 weight of solids. Now we have a new formula. So instead of weight of water, we place 0.36 weight of solids. Weight of solids, we still have weight of solids here, is equal to 120 pounds. This is equal to 0.36 plus 1 weight of solids, which is equal to 1.36 weight of solids, and that is equal to 120 pounds. So you can solve for weight of solids. Your weight of solids is 88.24. This is 120 divided by 1.36, which gives you 88.24. And then you can also calculate weight of water as 0.36 times weight of solids, or the other way to solve this is weight of water is equal to total weight minus weight of solids. So 120 minus 88.24, which again gives you 31.76. Now we have weight of water as 31.76 and weight of solids as 88.24. So now we go back to the question. We have 100% saturated soil, which again means S is 100% or 1, and saturation is weight of water divided by weight of void. So this means that volume of water divided by volume of void, and this means volume of void is equal to volume of water, which means that volume of air is 0. So volume of air is 0. Now we need to calculate the volume of water. We have weight of water. Gamma W is 62.4. So one more time, gamma W is weight of water divided by volume of water. When we have weight and we need to calculate volume, we can rearrange this formula, and the new formula is volume of water is equal to weight of water divided by gamma W. So weight of water, we have 31.76. Gamma W, we have 62.4 pound per cubic feet. So volume of water is 0.51, and then you can calculate volume of solids as total volume minus volume of water, which is 1 minus 51. Gives you 0.49 cubic. Next, the question is asking you to calculate void ratio. So void ratio is volume of void divided by volume of solids, 0.51 cubic feet divided by 0.49 cubic feet, which gives you 1.04. That's our void ratio. Specific gravity is weight of solids divided by volume of solids times gamma W, and you get 2.88. This table provides properties of some typical soil. The void ratio for different type of soil can be anywhere from 0.3 to 0.4 up to 0.9 to 1.4. So this is the range for void ratio, as low as 0.3, as high as 0.9, or even higher for soft clay, which is 1.4. This is void ratio. Which is volume of void divided by volume of solids. Moisture content, weight of water divided by weight of solids. Dry unit weight, gamma D, which is weight of solids divided by total volume. The range of numbers, it can go as low as 70, 38 for when we have clay, soft clay, and even worse than that is soft organic clay, so it goes lower. And then when we have a stronger material, dense uniform sand, it goes up to 115, and even here it goes to 134. Another property that is important is relative density, which is used to indicate the in situ denseness or looseness of granular soil. It is defined, so relative density, dr, is maximum void ratio minus in situ void ratio divided by maximum void ratio minus minimum void ratio. This is always a number between 0 to 100%. Then when you have your dr, relative density, you can describe your soil. For example, we have for a given sandy soil, Emax is 0.75, minimum void ratio is 0.4. Then they did the in situ testing in the field. Soil void ratio is 0.672. You calculate relative density, dr, and in this example dr is 22.3, so it's within this range, which then we can describe this soil as a loose material. The moist weight of soil. So weight is 40 pound, volume is 0.3 cubic feet. The water content and the specific gravity. So water content 13%, a specific gravity of soil solids 2.7. The question is asking us to calculate moist unit weight, gamma, dry unit weight, gamma D, void ratio, porosity, degree of saturation, and the volume of water. It's very similar to the example we went over earlier. Total weight, which is equal to weight of water plus weight of solids, is 40 pounds. Moisture content is 13%, which means that weight of water divided by weight of solids is 0.13. So from here, we get weight of water is 0.13 times weight of solids. We place this here, and we get the new formula. 0.13 weight of solids plus weight of solids is equal to 40 pounds, which means that 1.13 weight of solids is 40 pounds, which means that weight of solid is 40 pounds divided by 1.13. So when you do this, you get your weight of solids as 35.4 pounds, and then you can calculate weight of water as total weight minus this number, so you get 4.6 pounds. The question gave us a specific gravity of solids as 2.7. So you can calculate volume of solids as weight of solids divided by GS times gamma W. And volume of solids is 0.21 cubic feet. We also know that unit weight of water is 62.4 pounds per cubic feet. So you can calculate volume of water as weight of water divided by gamma W, which gives you 0.074 cubic feet. Volume of void is total volume minus volume of solids, which is 0.3 minus 0.21, so we will have 0.09 cubic feet. And then finally, you can calculate volume of air as volume of void minus volume of water, which gives you 0.016 cubic feet. Now that you have all of these numbers, moist or wet unit weight is total weight divided by total volume. Is total weight divided by total volume, gamma. Moist unit weight, dry unit weight is gamma D, so it's weight of solids divided by total volume. A total volume, yes. So now we have weight of solids divided by total volume. Void ratio is volume of void divided by volume of solids. So it's volume of void here divided by volume of solids. Porosity is volume of void divided by total volume. So it's volume of void divided by total volume. Degree of saturation. Again, degree of saturation, it means what percentage of percentages of the void is filled with water. So it's volume of water divided by volume of void. And then the last one is asking for volume of water, which is just